In this video, we're going to start to review what's called the binomial distribution, and we're going to use the Van Air Airlines example that I'm going to talk through and keep going with for several videos here. Okay, so let's say Van Air is an airline that operates small flights here between Victoria and Vancouver. Now, Van Air wants to answer the question, should they overbook? And if so, how much should they overbook by? So they have 18 seats on their plane. And should they overbook by 1 person, 2 people, 3 people, 4 people? So they're trying to determine this. And question, will all of the people who reserve actually show up? If that were the case, then you'd have these 4 unhappy people if you allowed 4 overbookings. Possibly. So if we overbook by 4 people, that makes 22 people, or 22 reservations that we allow for, because we have the 18 seats inside, plus we allow for 4 overbookings. Again, that makes 22 people. But will all of those people show up? Let's say there's a 90% chance that each of them will show up. So they each have 90% chance of showing up, including everybody in the plane as well. Everybody has a 90% chance of showing up, let's say. Little note, for the binomial distribution to be true, everybody needs to be independent of the others on this flight, so they can't show up together. They need to show up independently, so they each get the same 90% chance of showing up. Okay, so maybe then only 21 people will show up. If there's only a 90% chance, okay, that still leaves us with 3 overbookings here, but maybe just 20 people will show up. Again, that still leaves us with 2 overbookings. Okay, still not ideal. Or perhaps no more than 18 people will show up. In that case, there'll be room for everyone. So what should Van Air do? So if not everybody who books will actually show up, then maybe they should overbook. Maybe we'll have this scenario where there's room for everyone. So we can model the number of people who show up. To give this answer, let's model it with a binomial distribution. Again, these people need to be independent of each other, and each one needs to have the same odds of showing up. Okay. And if that is true, then the odds of them showing up, or the number of people showing up, will follow a binomial distribution. Okay, where right around 20 is about the highest number of people who show up with the odds that we have, and with, let's say, 22 overbookings. Okay, so let n be our number of reservations that we allow. So we're trying to ask this question, do we allow 19, 20, 21, 22, or just the 18? And where x will be the number of reservations who actually show up. So out of all of our total reservations that we allow, only a certain number of them will show up. And x is what we see down here. Most likely is that 20 people show up. That's not so good. There's only 18 seats. Odds of 18 people actually showing up are pretty low right now, but that's okay. We'll have a look at those numbers. And little p is going to be our probability of each individual person showing up, which we've set to 90% right now. And the probability of x will be the probability that x number of people show up. So maybe 18, or maybe 19, or maybe 20, or so on and so forth. So first question, what are the odds of the flight being exactly 100% full, of having room for 18 people and exactly 18 showing up? That is the ideal. We want the flights to run close to capacity without being overbooked. So exactly 100% full, there'll be no overbookings. Okay, and no empty seats. So we'll be at capacity, and there'll be no unhappy people, right? So that's the ideal. What are the odds of that happening with the numbers that we've chosen? Okay, so if they accepted 22 reservations, which we're starting with, let's start with 22 reservations, then X would be 18 because exactly 18 people showed up. And to get the odds of that exact 18 people showing up, we would use a p equals binom.dist of 18, 22, 0.9, 0. Okay, and let's have a look at what that looks like. So binom.dist of 18, 22, 0.9, 0 is the probability that we have exactly 18 people show up. These guys here. Okay, it's our odds of 18 people showing up, where this first value we put into binom.dist is the x. The next one we put in is the n. This was the number of reservations we accepted. The next we put in the little p. These are the odds of each individual person showing up. And now we put cumulative equal to 0 when we want the odds, when we want the odds of exactly a certain number of people showing up. In our case, exactly 18.